Oh, hello. Today we're going to learn about applications of trigonometry.
I don't know what that means.
She doesn't know what that means.
So we're going to look at some applications of the trigonometric functions. There are a lot of similarities with this topic and the equivalent applications topic from our previous function study unit. There's not too much I can say that will teach you what method to use to solve these problems, because every problem will describe a different situation that's going to require different skills to solve. They should just be an application of a skill that you've learned this unit, or multiple skills. But I can give you some pointers before I work through a couple of examples of questions that you'll see of this type. There are lots of different situations that can be modelled by trigonometric functions, because it's basically anything that moves in a circular or periodic motion. Anything like a Ferris wheel, or a pendulum, or a windmill, or planets. And it can be planets orbiting the sun, or rotating on their own axes, or the moon. And of course, if we're talking about the moon travelling, then that's also going to affect tides. If we're talking about the Earth travelling around the sun, that can affect things like temperatures and day-night cycles, seasons. All of this stuff could be an application problem. Now, to get your head around the problem, the first step is nearly always to ask the question, what is the period? Now, there are several different types of questions in this category, and sometimes you will be given the equation. In that case, it's very easy to work out the period, because you know that it's going to be 2 pi on n, or pi on n in the case of a tan graph. Other times you're not given the equation and you have to work out the equation, and in which case you're given enough information to determine what the period is from the context of reading the problem. Now, when you're working out the period, or you're working out an n value, in any sort of graph we could model it to a sine lots of n x plus b situation. Anytime you're trying to work out the n value, bear in mind that nearly every application problem has a period that will be an integer. So if we're dealing with the Earth rotating on its axis, like a temperature scale, you're going to get a period of something like 24 hours. Or if you're dealing with a windmill, you might have a period of 1 minute. If you're dealing with a pendulum, you might have a period of 15 seconds. You're always going to get periods that are a time unit, and often an integer, but not always. You might be interested to have a problem on Halley's Comet, which comes and visits the Earth once every 75.32 years. But note that none of those values have pi in them. In our problems we've done so far, you're used to seeing things that have a period of 2 pi, or 4 pi, or pi, or pi on 2, something like that. You're not going to get those with application problems. You're going to get values that are periods of 24, or 1, or 15. So remember that since our period is 2 pi on n, for nearly all our sine and cos graphs at least, then the n value is going to have a pi in it. So don't be surprised if you're dealing with functions that have sine and our n value is something like pi on 12 lots of x plus something. And that pi on 12 could be pi on 365, or it could be pi on 60, or it could be 2 pi on 3. It could be anything, but you're nearly always going to get a pi on top of that n value. So don't be surprised about that. And if n value isn't given to you, but you have to work it out, then you're going to get answers that are going to look like that. Once you know the period, it's also going to help to work out the maximum and the minimum values, which we can always get from our C and our A values at the front. So remember, or maybe the equation's not given to you and you have to determine them from the context, but it's not hard to remember that I always like to visualize this with a little graph, that just remember we've always got our maximum and our minimum value, and halfway between those maximum and minimum values we've got our C value, and the distance between our C and our maximum value is our A value. So you can always, from any sort of context, even if it's just a written problem that tells you what the maximum is and the minimum is, or the median value, you can use those to work out C and A. Or if the question gives it to you as an equation, gives it to you in this form, then use A and C to visualize in your head. So I might start by writing, well, I'm dealing with something that's, if I'm reading a question, I might say, okay, so from this question I can work out that the period is going to be 1 day or 24 hours, and my maximum temperature is going to be 27 degrees inside the house, and my minimum temperature is going to be 19 degrees or something like that. So if you can work that out from the equation, if it's given to you, or from the problem, if it's written as a worded problem, then that will help you on your way. Now, if you get a question like this in the calculator section, make sure you're using your calculator to help you. Plot the graph on your calculator, make sure that you understand the bigger picture before answering specific questions. So it always helps to just get your head around the problem. And sometimes that can take a good part of the time allocation for a problem like this. Also, don't forget to give approximate decimal answers for application problems. What I mean by that is you might have plugged an answer into your calculator and got something like, your calculator has spat out an answer of the temperature is going to be 15 root 3 on 2 degrees C. This is not an acceptable answer for an application problem. Giving an exact answer is not as good as saying, I've typed this into my calculator and I got 12.99 degrees C. How far you go with accuracy will either be defined in the question, or if it's not, just use common sense and be sensible. So in summary, there's a few key points. The first is, let's work out the period and the minimum and the maximum, and if the question requires you to, use the period and the minimum and the maximum to determine your A, B, C, and N values. Use your calculator if you can. Make sure you give approximate answers if you can, not exact, and don't forget units. Now that's a lot of stuff to help you around the problem, but it's not actually solving the problem itself, and I can't really do that because every single problem is going to be different. But if you remember those things and tackle every problem knowing the skills that you've got from this unit, then you'll be fine, I have no doubt. So let's have a look at a couple of problems of this type. So this is a question that gives us the equation, which we can see at the top there, and the question is based on this situation. A wheel is mounted on a wall, so I like to start with the diagram. We've got a wheel that is mounted on the wall and it rotates, so it's spinning, such that the distance d of a particular point P from the ground, so we've got a point here, P, and we're measuring the height of that distance from the ground, and that is given by the equation d is equal to 100 minus 60 cos 4 pi on 3t. Now, I said in my previous video that I like to straight away think about the period. I also quickly read through the questions and I noticed that question B does ask for the period. So I'm actually going to jump straight to question B. You could also do question A first and just follow through, but I like to think about the period. So how long does it take for the wheel to rotate once is essentially asking for the period, and we know that our period is equal to 2 pi on n, where n is equal to 4 pi on 3, so I'm going to do 2 pi divided by 4 pi on 3. The 2 cancels out with a 4 and leaves us with 2. The pi cancels out with a pi, and the divide by 3 can go onto the top, and so we end up with an answer of 3 over 2. Given that our units for the question, it says here, is given by the rule where t is time in seconds, so that's 3 over 2 or 1.5 seconds. That's our period, and it's also the answer to question B, how long does it take for the wheel to rotate once. Question A, let's go back and answer that one. How far is the point P above the ground when t equals 0? That means we're just plugging in t equals 0 into our equation. D is equal to 100 minus 60 cos 0. Cos of 0 is 1. Don't fall into the trap of just assuming that plugging 0 into a trig function gives you 0 out, which I've seen a lot of people do. And so that's 100 minus 60, which gives us an answer of 40. Let's not forget units. And again, let's double check the question. This is in centimeters, so our answer is going to be 40 centimeters. Question C says find the maximum and minimum distances from point P above the ground. To find our maximum and minimum distances, we basically know that a maximum range of cos can go up to +1 and -1, and so we can basically plug both those values into our equation to find our maximum and our minimum. So that's going to be 100 minus 60 is going to give us our minimum, which is equal to 40, and 100 plus 60 is going to give us our maximum, which is going to be 160. So that's, again, both in centimetres. That one's our minimum and that one's our maximum. So that's usually pretty easy to work out, just remembering that our cos and our sine functions both have a maximum of 1. And so all you're really doing is taking that cos or sine bit, turning that into 1 and working out what our maximum and minimum are. Question D says sketch the graph of D against T. Now this particular question doesn't give us a domain, which is quite unusual. Usually it'll say over a particular domain or for 3 revolutions of the wheel or something. Let's just make up a domain and state that we'll do this for 3 revolutions of the wheel. Given that we know our period is 3 on 2, that's going to give us 3 revolutions is going to be 4.5 seconds. So let's go down to there, which is 4.5 seconds, and divide that into 3. So that's going to be 1.5 seconds and 3 seconds. That's going to be, we always need to make sure with application problems we label our graphs appropriately. They're not X and Y anymore, they're T, which is in seconds, and they are D, which is in centimetres. And we know that our minimum, I like to draw a little dotted line for our minimum, which we worked out to be 40. And a dotted line for our maximum, which we worked out to be 160. Now let's think about the shape of the graph. This graph here has a negative cos, so it's actually going to be a reflected cos. We can also think about that by recognizing that we're starting at the minimum at 40. So that means this is going to be our start point here. We're going to get another minimum the period away, another minimum the period away, another minimum the period away. We're going to get maximums halfway in between each of those. And so trying to put in a smooth curve as best I can. Not easy on the iPad. Remembering that we're trying to finish with a gradient when we're sketching graphs. We try and finish with a gradient that's close to 0. We don't want to just finish by drawing a straight line going through there or stopping. We also need to stop at the endpoint. This endpoint we should label, that's 4.5, 40. We should also label our original endpoint, which was 0, 40. The question doesn't explicitly ask us to label any other minima or maximum or any other points, so we'll leave it at that for now. Let's move on to question E. Question E stated, in the first rotation, find the intervals of time when the point P is less than 70 centimetres above the ground. So 70 centimetres is obviously around here somewhere, and there's going to be an occurrence there and an occurrence there. So to find those points, we need to solve this equation. 70 is equal to 100 minus 60 cos 4 pi on 3 t. Now, if this is in a calculator section, I could just type that straight into my calculator. It might not be. We might have to solve this manually, but that's not that difficult. Let's do it manually. First, I'm going to subtract 100 and get negative 30 is equal to negative 60 cos 4 pi on 3t. Dividing both sides by negative 60 gives me a half is equal to cos of 4 pi on 3t. Solving this equation, whereabouts is cos positive? We know cos is positive in that quadrant and that quadrant. Our base angle for 4 pi on 3t is going to be equal to, the base angle for cos is equal to a half is pi on 3, and we're also going to get another value at 5 pi on 3. Now for each of these ones I can cancel out my denominator, I can cancel out my numerator. I get t is equal to 1 on 4 and 5 on 4. So remember that those are seconds, and those gives us these two values up here, 1/4 and 5 on 4 seconds. Now the question actually asked us where is it less than those values. So in the first revolution, I could say that we get solutions d is less than 70 where x is less than 1 on 4 seconds, or x is greater than 5 on 4 seconds in the first revolution. And that's answered that question. The next example we're going to look at is one where the equation is not given to you, at least not in any usable form apart from just a blank template. So this particular question, we've got a profile of a volcano shown by this, and it tells us that a cosine function of the form h of x is equal to ax cos nx plus b can model the profile before the crater was formed as the result of an eruption. So that's the line including the dotted line at the top. That's a cos graph. Obviously it's been truncated a little bit, something's happened to it, but the general form of the cos line is shown as the dotted line at the top. For question A says determine the exact values for A, N, and B, given the maximum height before the eruption was 4 kilometers, while its base spans 50 kilometers. So there's a few things going on here, but you should notice immediately that it's telling us in the templates that it's A cos nx plus B. There is no value in here. There is no constant, which means there's no horizontal translation. We don't have to determine that. Now, sure, you could look at that graph and realize that anyway. We could also look at the graph and realize that A is going to have to be a negative value. But we're using the template that's provided to assist us. So we need to work out what A, N, and B are. What information do we have? Well, I always like to start with the period. And we can use that to find our n value. Now, looking at the graph, we can see that, from the question, the base spans 50 kilometers. So this clearly has a period of 50 kilometers. That's our units that we're dealing with here. And we know that our period is, we know that n is equal to 2 pi over the period. So that's going to be pi over 25. That's going to be our n value. In terms of A and B, we know that we can get those from our median value is B, and our distance between the median and the top is going to be our A value. Assuming we start at a height of 0, that means that halfway between 0 and 4 is our B value. So B is equal to halfway between 0 and 4, which gives us an answer of 2. And our A value is the distance between 2 and the minimum. And so that's also going to be equal to 2. We need to recognize that this is reflected. And so our A value is going to be negative, even though our amplitude is 2. That's all question A is asking us to do. A similar question might say, and state the resulting equation. This one doesn't. It just says we have to determine values for A, N, and for B. Part B asks us to determine the distance across the crater formed after the eruption, given it is parallel to the ground and at a height of 3.681 kilometers. So if we've got a graph that looks like this, we're essentially trying to find the length of that line there. That's the distance across the crater. So to do that, we know that this fits a cos graph. We have to find that point there and that point there. We're going to solve this. We're trying to find where our y value is 3.681 is equal to our equation that we found, negative 2 cos lots of pi on 25x plus 2. Typing that into my calculator. Remember that every time you are solving something with a calculator, you should at least show enough working out to show what you've solved. So this line of working here is incredibly important. But on our calculator, I'm going to type in solve 3.681 equals negative 2 cos pi on 25x plus 2. We're solving it for x, and we're solving it over the domain. We know that since we're going from 0 to 50 on our graph, we know that our domain in our calculator is between 0 and 50. That spits out two values, so we can write those down on our paper. X is equal to 20.4 and 29.6. So the question's actually asking us for the distance, which is going to be the distance from this point here to that point there. That's going to be one of these subtract the other. So 29.6 subtract 20.4. Now it looks like the answer is going to be 9.2. Let's type it into our calculator. So I'm going to go up and select that and then subtract that one, and we can actually see we get an answer of 9.1. It always pays to do the subtraction with exact values rather than the rounded to one decimal place. All this is sort of academic though, because the question actually asks us to express our answer to the nearest kilometre, and so we can say that that distance is approximately 9 kilometres, and we have answered the question.